today we will release something that's of grand importance not only for us, but for a greater community of friends of messaging or building infrastructure.
And the industry.
For the industry. And David Ingham, who has been leading this effort on the standardization front for quite a while and is one of the world's best experts in that field, will explain to us what that is. What is it?
AMQP. So
it is what does AMQP stand for?
It stands for the Advanced Message Queuing Protocol.
Okay. So where does it come from and how do we use it?
Okay, so AMQP started out in the financial services industry.
Mm-hmm.
JP Morgan Chase were the originators of this protocol. And JP Morgan Chase, like many financial services firms and like many large organizations, they're faced with a challenge of integrating message-oriented middleware systems. So these sorts of organizations use message-oriented middleware throughout their systems, particularly in their back offices, for connecting together various parts of the financial processing chain.
Mm-hmm.
And message-oriented middleware has been extremely useful at addressing that problem. There have been some significant players in that space that have kind of dominated that space. And one of the characteristics of those products that they've been using is that all of the protocols are locked down and proprietary. So this means that if a company decides that they want messaging, they pick a particular vendor, they kind of have to stick with that vendor for all of their messaging needs, because mixing is impossible without building application level bridges, and application level bridges are hard to manage and complex things, and application bridging is the only choice you have if you want to connect these islands of message-oriented middleware.
It seems almost like a crazy thing that the customers would come up with or would start an initiative doing that.
Right. So it shows you how bad this problem is, right?
And so we did so when you look at some of the players who are in this, we don't need to go into names, but a lot of those folks who have been building messaging systems, they now were in that XML and SOAP initiative, and then we all shook hands and we said, well, we have now solved all the problems of the world, and then you had this XML and SOAP stuff, which was kind of interoperable, mostly with all that complexity that it added, and then they were happily, however, who were the incumbents in the messaging space were then happily saying, well, yeah, it interoperates, but the thing that we have is faster.
That's absolutely right. That's absolutely right. And so you're right in raising the point that normally these kinds of standards, like the XML and SOAP standards, they originate in the software vendor community. It's large software firms getting together and trying to address a problem that they perceive that the customer has. This is a case where JP Morgan Chase had a real problem. They decided to solve it themselves. They built something themselves. They then pulled together a community of other user firms that were facing the same challenges.
So they basically just went out on the street, up and down the street in New York, and kind of said, hey,
and in the city of London, they pulled together a group of firms, and then they got some technology firms involved, and they changed this thing from an initial prototype that they built into something more fancy, and they formed a consortium of interested companies called the AMQP Working Group, and the role of the AMQP Working Group was to define and standardize this protocol. And over the few years that group was together, there were several iterations of that protocol, and it grew to around 21 firms. And Microsoft joined in 2008. Mm-hmm. And that working group created a version of AMQP, the 1.0 version of AMQP, and then they took that to the OASIS standard setting organization for formal standardization. Mm-hmm. And that happened in October last year. So in October, Oasis said, okay, here is AMQP standard. And now there are plans afoot to do further standardization through international standardization. So this is through the ISO and JTC1 group.
Mm-hmm.
And this all helps to take this protocol and to tell the world that this protocol is a recognized standard for
Mm-hmm.
doing interoperable messaging. So we haven't spoke about what this protocol does.
Yes.
Maybe we should cover that.
That would be a good idea, because I was about to ask that as I was trying to raise my voice. So what does it?
What does he do?
Yeah. So what is the? So we had the nirvana and happiness of SOAP and XML that unfortunately sometimes made things a little slower than they needed to be. So this is apparently something that's different. So how is it different? What does this do?
Well, it aims to solve a conceptually very simple problem, which is how to reliably transfer messages between two endpoints. That's the full scope of the protocol.
So I have endpoint here, you have an endpoint
Yeah.
there, and wait, can we see that? Yes, we can see that.
can see.
So endpoint here, endpoint there, and I give you a message.
Yeah.
And now what the protocol does is it helps me understand whether you actually got that.
Yeah. So, first of all, there are different scenarios about how we want to exchange these messages.
Mhm.
These might be messages that we don't really care that much about if they get delivered. We'd like them to get delivered, but if we miss one, it's not the end of the world, because there'll be another one coming along in a few seconds, and
Okay.
so we want to send these messages best effort.
Okay.
So we can do that if you want. You can send me a message and you can say, I've settled this message. I'm not maintaining any history about this message. I don't need an acknowledgement for it. And you just send me the message and I'll say, okay, thanks, and I'll go ahead and process it. That message, if there is a network problem or some other problem in the system, there's a potential for it to get lost and not get delivered. Right? So we call that a most once delivery. So
Okay.
the message will be delivered to the end user at most once. Now, you might say that, no, that's not good enough for me. I need that message to get delivered. So, okay, so what we'll do now is we'll use the protocol and we'll configure it slightly differently. And you send me the message, and then I'll send you essentially an acknowledgement back. It's not strictly an acknowledgement from a protocol point of view, but conceptually that's what's happening, right? You send me a message and I send you an acknowledgement back. And you say, okay, great, I know he got it, now I can move on with my life, right? If you don't get the acknowledgement, then you're scratching your head thinking, oh, something went wrong. Maybe the message didn't get to him. And that is one of the possible things that happened. The message didn't get to me. The other possible thing that happened is the message got to me and I sent you the acknowledgement, but the acknowledgement didn't get through to you.
Oh, yes.
Right? So in that case, what you're going to do is you're sat there, you've sent the message, you didn't get acknowledgement, you're going to retransmit that message. So you're going to send it me again. Now, I get that that message. That might be the first time I've seen it. It may be a duplicate. So in that scenario, there's a case for duplicate delivery. Right? So we call that at least once. So we're going to get the message at least once, but we might process it multiple times if you send me a duplicate, not knowing I got the first one, right? So the other mode involves a three-way handshake. So you send me the message, I send you an acknowledgement, and then you send me a message saying that you got the acknowledgement.
Okay.
Okay? Now, what that allows me to do is, well, it allows me to be able to tidy up a list of duplicate messages that I might be holding. Right?
Yeah.
So I know now that I'm never going to get a redelivery of this particular message.
Not for the purpose of, me not knowing whether.
Exactly. So dealing with duplicates involves maintaining a table of the messages that you've already processed, so you don't actually hand the message off to your app multiple times. This third handshake here allows me to prune that table down, so I don't have to record every message that I've ever received forever.
Okay. So that's a basic pattern of exchange that's there. What is But it's all independent. It's a peer-to-peer exchange protocol, effectively.
It is.
That's what it's for.
It is, and it's some characteristics of the it's a binary protocol.
Mm-hmm.
So
that's where this is where the grand secret differentiation is from the XML stuff, that it is truly and optimized for binary.
it is. It's an optimized Y-level protocol. It's reasonably efficient.
Mm-hmm.
It's not the most compact Y-level protocol that you could develop, but it's the design goals were trying to meet a balance between efficiency and also flexibility. We want to support a broad range of scenarios with this protocol, right? So it has that balance between compactness of format and also opportunity for extensibility of the protocol.
And it's self-expressive in the way that it carries metadata with it, which you.
That's right.
I mean, if I was building the most efficient possible wire format, I would probably have the metadata about what I'm sending external to the wire, and then not send it along with it.
Yeah.
But here I'm sending self-contained messages which have everything that they need.
Yeah, the protocol defines a type system, and that type system is used to describe the actual protocol messages that are exchanged, but it's also used to define the actual messages that are exchanged. So there's a format for the messages that at the high level is basically consists of the ability to set attribute value pairs and the ability to specify a body. It's actually more flexible than that in terms of what you can do with the message representation. But from what the user tends to see through the APIs, it kind of looks like that. And the body of the message can be a raw stream of bytes that you provide, but it can use the AMQP type system to encode the contents of the body. And that might be simple types like strings and integers and things, or it may be more complex types like maps and lists.
So I have a map is effectively a dictionary, which allows me to then make which effectively gives me key value pairs that can contain key value pairs and can contain so I can make structures like this.
So you can get quite complex. You can get some quite complex message structures should you so desire. And the advantage, this is defined in the protocol, and it means that different client libraries that support this protocol are able to render that message into an appropriate format for their languages. So that's something that we should probably talk about too.
Yeah. I had one more point. Which I'm forgetting right now. Oh yes. So people will, before we get into the mapping and how the languages and the secrets and how surprisingly on Microsoft some of those aspects are, the people will say, well, we have the one protocol that would solve everything already. Why are you making a new one? So there's obviously I can send messages through HTTP. Why do I need this one? And I think there has to be something said about the different exchange patterns you can have around messages.
Yeah.
And the fact that HTTP is a thing where you have you use a socket to exchange a pair of messages in a certain sequence, but AMQP has a notion of there's a connection, and then you have multiple things that are maybe happening in there, right?
Yeah, so we love it, just to be clear for everyone watching, we love HTTP.
Yes, yeah, oh yeah, we love HTTP very much. We're just saying
that maybe it's not the right protocol for every scenario.
Exactly.
Right. Yeah. So the point that you were raising is that with AMQP I can establish a connection, and then over that connection I can have multiple asynchronous messaging exchanges happening. So the way to think about it is that you've got a big pipe that represents the connection, and in that pipe I've got some smaller pipes that are handling independent conversations. And I should have said up front that the protocol is completely asynchronous, which means that it's not a request-response style interaction like HTTP. I can send multiple messages in one direction and then receive a single frame in the reverse direction that acknowledges all of those messages that I've received. Right? And each of those conversations that are happening inside that pipe, inside that big pipe, are independently flow controlled. So this means that, imagine a scenario where I've got, I'm pushing some telemetry information from a device, and that telemetry information is coming fast and furious, and I'm sending it down the pipe and to be consumed at some service at the other end. But I also want to be able to do some command and control back down to the device. Well, I don't want those command and control messages to be clagged up simply because there's a burst of telemetry traffic, right? So I want to have one socket because that's efficient for me, but I want to maintain those independent conversations and be able to flow control those conversations independently, so I can maintain a responsive command and control channel while still utilizing the bandwidth for the telemetry.
So it allows you to manage that socket capacity on that socket,
if you will. Yeah. So that's one of the key. Like when people look at the AMQP specification, I won't try and kid everyone that it's a simple protocol. It's not a simple protocol. There is quite a lot of complexity there, but the complexity is for a purpose. And features like this, being able to have what we call link level flow control, is a really useful feature when you get into like the scenario that I just described.
So in the completely while we stay above the things, in the completely theoretical case that you might have a thing somewhere where you have a client and the client wants to talk to that thing, and that thing happens to be a broker kind of thing which has multiple queues, and you may be interested in sending some messages, and then you have a mailbox where you can get messages from. That means that multiplex nature of it means that you can actually go and make a single connection and then send messages to multiple destinations that are sitting behind this, and it can also at the same time solicit messages from one of those places behind it, and it all happens on that one precious, wonderful socket that they've established.
Because without some capability like this, flow control is sort of limited to TCP back pressure.
Yes, which means you're pressuring everything back.
Exactly. All of the traffic over the socket is affected.
So, having that as a protocol, what we've done now is we've put this into Service Bus. So we've had that as a capability in preview.
Yeah.
What we call preview in production. What we do is we do some fairly. Since we've now learned how to build services, we are becoming very daring, and we're putting stuff that's not quite ready yet into basically just be able to put that into the production system without causing too much trouble. So we've had that, and so as of today, what we're doing is we're announcing that that's now a fully production ready. You can use this in your systems with SLA and everything. Generally available feature. So now we have a cloud-based AMQP service, and that's enabling quite a few interesting things in addition to what we had before, kind of in a production-ready way. As we've so far had HTTP as our protocol, and we're a multi-protocol service, and we're keeping this up, and we're making everything better, so we love HTTP, obviously, to get messages, send messages. And we've had our own .NET client, which is speaking a protocol that we call in quotes, because that's not an official name, SBMP, where we are in perfectly harmonious agreement with the rest of, so far, of the messaging industry, and having something that is completely proprietary. So we have, and now we've chosen, and we're taking that step to say, nope, we're going to go and make that protocol AMQP now in stages, the primary protocol for Service Bus. And so that's today the first stage that we're releasing the first level of support for AMQP into the system. So that's now opening up a number of interesting scenarios, because we will have, of course, the Service Bus client, so the .NET client, has a built-in way to go and use AMQP.
Yeah, that's really straightforward. So if you've ever used the Service Bus.NET client, then you'll know that you configure your queue clients and your topic clients using connection string, You get that connection string from the portal, and you just plonk it into your app config file, and you're good to go, right?
And you're using AMQP right now?
Yeah, so the way to use AMQP is you take that connection string and you append to that connection string semicolon transport type equals AMQP, and that configures the client library to speak AMQP versus SBMP.
Yes.
Yeah.
That is so there's a number of features now that we are still working on to enable on AMQP. Over time, we're kind of migrating towards AMQP, if you will. And by the way, not only, so this is for brokered messaging, but also the relaying capability that we have, we're working on making that AMQP enabled. We're very thoroughly changing Service Bus's primary protocol to become AMQP 1.0. We actually, the relay internally, and some of the paths that we have internally inside the system, we have already switched to AMQP in production, so you're using AMQP even without you using AMQP. But the .NET client is not the most interesting one. I think the most interesting thing, certainly from a perspective of a Microsoft world perspective, is that we're working very close, happily, with folks who are building Apache client, which are building, they already said it, AMQP clients, to make sure that they work well against Service Bus for other platforms, and other platforms meaning down to tiniest devices.
Right.
So you have made great and powerful friends in that world.
I've made some good friends. So the Apache community, in particular the Apache Cupid community, they've been working on AMQP for many years. They have lots of AMQP components. And they've been working with AMQP 1.0, and they've produced a few different components that we've been working with in conjunction with Service Bus. So one is a JMS library. So JMS is the API standard for messaging in Java land. So if you're a Java developer and you've done any messages, you will have accessed whatever product you're using through the JMS API. What this client library from the Apache guys does is it provides the API abstraction of JMS, and then it uses the AMQP 1.0 as the underlying transport. Mm-hmm. Because JMS is purely an API standard. It says nothing about the underlying transport. So if you get a JMS product from different vendors, they'll use different proprietary protocols, they won't talk to each other. But this client library uses AMQP 1.0. So this means that a Java developer can write a standard JMS application using all the concepts that he's grown to love from his previous JMS provider, and he can configure that to use Service Bus as the JMS provider. So I can write standard JMS app, and my topics and queues are Service Bus topics and queues. So that's great in itself.
Absolutely.
Right? That's, choosing Service Bus as your JMS provider, obviously a step up from whatever.
Absolutely. Whatever you're using for.
Whatever you're using for. But the really nice thing is that you can mix and match those things. So I can have some components in my application written in .NET using the Service Bus client library, and I can have other components in my application running Java, either on Windows or on Linux, using this JMS client library to exchange messages via Service Bus with the .NET component. And these messages are exchanged at full fidelity, and this is by virtue of what we were saying earlier about the type system. So it means that I can send a map message in JMS and receive that in .NET as a dictionary, and all the structure is preserved, and so you get this full fidelity exchange of the business content. So the JMS library is one that we've worked with, and that's great on its own, but because JMS is this API standard in the Java world, it tends to be the way that frameworks integrate messaging into their system.
It's the ODBC for messaging in Java.
In Java, yeah.
Or JDBC. It's kind of how that works.
Yeah. So it means that whether you have a JEE framework or some other lightweight container, something like Spring, you can use JMS to plug in Service Bus into those environments. So that's quite nice. The other the other libraries we've been working with, also out of the Apache Cupid group, is something called Proton. So Proton is a couple of things. It's an implementation of the AMQP 1.0 protocol stack. And in fact, they have two different implementations. They've got a C implementation and they have a Java implementation. And then on top of that C implementation, they provided several different language bindings for interpreted languages. So PHP, Python, Ruby, Perl, for example. And they all use this C core. And so this means that you can write an app using PHP or Python and similarly exchange messages with your Java and JMS components or via Service Bus.
Is there something for the adventurous JavaScript people?
There is something in development, but there isn't something available right now.
So it is possible to do AMQP in Node. It's just not there yet.
Right.
So that's happening, but that's in progress, and it's a matter of weeks, months, years.
Yeah. Well, I know that there was. Can I mention PayPal? I've just mentioned PayPal. So
Yes,
there was a presentation, a presentation by a fellow from PayPal at ApacheCon recently, where he demonstrated a JavaScript client library for Node.js that he'd built around that Proton core, that Proton C.
So effectively a binding then down into that C library.
Yeah. Now there's also some work building a pure JavaScript implementation of that. So it's coming. It's not there today, but I would imagine it will be pretty soon.
So there's an interesting shift there in because that's something we take very seriously in the sense that it is more likely we're going to help that to be good and flourish, and that we'll be very, very happy if the Apache Foundation builds great tools and we're actively involved in that, rather than go and do it the traditional Microsoft way of saying whatever they built can't be any good because it wasn't built by us. So we're actually very excited about the C. I'm specifically excited about the C implementation because that's designed specifically to scale down to the little stuff.
It is. Yeah.
And so if you have something that is based on Raspberry Pi, or if you go further down on an Arduino is kind of the plug and play board for the geeks where you can go plug things together, but then the soldering community, they're building stuff that is on one board, and there's also the professionally soldering community, which are building actual devices, and a lot of them run some minimal, if you want to call it, operating system, on some embedded platform, or they run on Linux, and so having a client that's in those devices to talk to cloud infrastructure or to a local system, that's also very exciting.
Yeah.
Now So this is what we're releasing today, making generally available today, is Service Bus Service. So that's in
right.
the cloud.
That's right.
And we have this thing that we also ship on the side, which is Service Bus Server. That's not being updated, but it will be.
That's right. So today, the version of Service Bus for Windows Server that's out there now doesn't support AMQP, but it will do in the next release.
Yes. So we can't say when that next release is going to be, mostly because we don't know yet, and even if we did, we would probably get into some significant trouble because that's a bigger thing when you go and release some software on the server than some other people release some things too, and you don't want to talk about dates. So the next version of that will support that. What else?
I think we've about covered it.
I think we've about covered it. So AMQP is something that is that we support in terms of libraries, that we support in terms of working with people who are building other AMQP clients. It is not something that if you're building applications will have to go and. I mean, of course, if you want to read the wonderful technical writing of David Ingham, I think you wrote some of that. Right?
I wrote some of it. Then colleagues at JP Morgan and Red Hat.
So you can go and read the specification in all of its wonderful glory, but the point of this protocol is not that you, if you're building business applications, ought to read it, but that you ought to know that it's there, and then you can use that as a keyword as you're searching for things you can use to go and connect up. So Apache Proton is one of the things that you can go and take a look at, or Apache Cupid Proton. And we're, I think at this point, very happy to be, have a broker, a system that speaks AMQP that will actually be more pervasive in its use of AMQP. Anything that's in Service Bus will eventually be something that will be addressable through AMQP. But truly speaking, if you're using an AMQP broker, if you want to use messaging middleware, if you use us or if you use someone else's broker, we'll be happy if you use AMQP 1.0 because we believe that that part of asynchronous middleware, asynchronous messaging ought to be interoperable and ought to be using an interchangeable protocol. That's obviously the wish of the customer landscape as expressed in that AMQP committee. And so we're effectively happy if you, whatever you use, as long as you use something that supports a standard. And so that's the thing that we're doing today, is like we are starting to say goodbye for proprietary messaging protocol here, and we're moving towards AMQP, and this is the first milestone. Thank you, David.
Thank you, Clint.
Thank you for your time, and we'll see you next time here on Subscribe, and we might actually go a little bit more in detail with another session with David in a few weeks.